be to kind of give you an idea of how this is going to start looking. Again, this is a prototype, and I'll be ordering another board which will actually integrate a different FET than what this board's actually designed for. I've already made several of these. A lot of people are already using these in their UTV. Mainly a couple of guys I know that race or that do woodland trails that have a lot of accessories. On the rear here, this is basically how I plan on doing my connections. These basically have pigtails coming out and wires directly soldered to pads. These are relatively high currents that will be running through these to run bars. So this is a test board, and I've got this connected, and the main focus of this video is we want to test all of this extra hardware that's on here, mainly the 485 driver and the optoisolator that I'm using to actually isolate 12 volt inputs, which would be your switches for your lights, to the 5 volt signal that the STM8 needs to see. And this is what's going to enable, those two things are what's going to enable this to function with some kind of external input. Now, whether that be 485 communicating with something else a little bit later in the video series, that'll be a more than likely a CAN bus adapter. Same thing I did on the 800S to actually read the speed and the reverse position switch, so you don't have to mount a micro switch or something like that. You can just pull it straight off the CAN bus and have that reverse light turn on when you want it to turn on. And in my application, the convenience feature that I'm looking for on my 1000S that I miss from the 800S that I had is automatically turning on rock lights. I've kept my 100S fairly basic. Right now it only has a winch and a light bar. When I add this system, I'm looking at adding everything that I had on the 1000S, and that being radio, the winch that it has now, the light bar will be an accessory. I'll have rock lights, I'll have reverse lights, and I'll probably have some more additional forward and reverse lighting. And I'll probably have some kind of rear and forward flashing light. Again, I participate, I volunteer for the rescue squad, and we use ATVs all the time. And it is beneficial to actually be able to turn on some kind of light to let riders know, especially if it's getting later at night, that you're in front of them, and let them know that something's going on so they can get slowed down. But we'll get right to this, and we're going to basically focus this video on the RS485. We'll probably do some things that it shouldn't really affect this, but we are going to do some things to this just to make sure that this is protected. And also this optoisolator, we're going to send in some signals and make sure that we're getting the conversion that we want and not exceeding this part's capabilities. On these optoisolators, that is probably the safest way. If you don't know what that is, that's basically where you're taking, a simple version of it is basically there's a LED and a light sensitive transistor. That's basically, you supply 12 volts, it internally triggers the transistor off of light. So you actually are optically isolated electrically from the circuit. Now granted, all this is going to be on a common thing. This 12 volt here is going to be the same 12 volt that ends up here. But there's a long wire attached to it, and other things could be happening, interference wise and things like that, especially if you start getting close to like the AC stator wires or something of that nature. But I don't think we're going to have any issues, but we are going to test to make sure that that actually works. So let's get to it. Okay, I've set up a power supply, and I'm actually going to set this at 13.8 volts, and I'm going to set a current limit of a ½ amp. Okay, so like in the previous videos, all of these boards have visual indicators to show you voltage rails. In this case, this is the right side is the 12 volt, that we have power coming in, and the left side is indicating that we have the 5 volt regulator is working. and the 5 volt regular is actually on the back of the board, and all of the circuitry for that is on the back of the board. The additional things that are going to be on the back of the board are going to be the a few resistors for current limiting on the inputs, on the 4 inputs that we have, and there's an LED bank that the microcontroller or MCU can control. In the final version that I'm planning for 1.1 with the new FET, I'm basically going to put all the LEDs on the back, so that they're all in one place. That way, if you really wanted to, I plan on putting these in aluminum enclosures, and that's what I've been typically making, and there's no indication whatsoever. So the way that most guys are programming these is they pull the case apart, hook everything up, get it working, and then just basically clamshell the case around it, and it encloses the LEDs. Some folks are probably going to want, it's a cool thing to have, is blinky lights. This will be conformal coated, so you can leave that exposed. Okay, so basically I've done a really simple hookup, and this will kind of give you a better idea about what I mean by low current switching. I've got this little small switch running these really, these are actually wire wrap cables or jumpers. These are really small conductors. When you're done with this, and I'll use bigger stuff on the RZR, but it's just to kind of show a point and just make it a little bit easier on the test bench here to put together. And I'll give you a close-up shot of this here in just a sec. Basically what we're testing is I've got one side of this switch attached to 12 volt, and the other side is attached to the input. And what we're looking for is this opto isolator IC, is when I apply a switch, does it actually convert that down for us to 12 volt. Now it's really not doing a conversion, basically it's doing a switch that's light based. And I've tested all 4 of these inputs and they work just fine and go down to the STM. And I'll just kind of take it apart here and kind of show you what I did. Okay, if you take a look here, again, really small conductor wire. We've got a little mini micro switch going up to this little 4-pin header. Each one of these pins is an input. So if you apply 12 volts to one of these pins, you can do something with the outputs. These can be really, a lot of applications. We're not talking about big current draws here. We're talking about, in a milliamps of current that we're processing through this switch wire. So imagine that you could actually use this switch in your dash on your RZR, or any other switch that you can find. As long as it has any current rating at all, it's pretty much going to work. And you're going to be able to control big currents with this. A lot of relays. I think on the relay that I've got, I think I have 40 amp relays, and I believe the switch has to be rated at half amp or an amp just to drive the solenoid. Well, this isn't the case with solid state. Basically you just need to be able to develop a voltage to meet the requirements of this opto isolator, and I'm looking at it, it's going to be around 8 to 16 volts, and you're going to be looking at just a few milliamps of current to drive this, and that will actually get the signal to the STM8 microcontroller. And depending on the programming, and I think the default that I'm going to use is basically one of these inputs will be ignition sensor. It will turn everything on or off based on a timer. I think I'm going to probably set that at about 30 seconds. So that's one of the inputs. The other input will be used for output 1 and another input for output 2. I don't really have a good plan on what I'm going to do with that fourth output, but I'm sure I'll come up with something, and it'll matter a lot more once you start bussing these together, because once you actually hook this 485 up to what I plan for the master on the 485 bus, as soon as it sees 485 traffic, it's going to to not do the default. It's basically going to become a dumb device. It's going to send what it sees as inputs, and it's going to wait on that controller to actually tell outputs. But in standalone mode, I plan on coming up with something default, especially something that'll work in the RZR. You know, and that's the easiest thing that application wise that you can really do. Because like I say, initially I just want to do my winch and light bar. Later I want to do the winch, the light bar, the radio, flashy lights, rock lights, etc. And that allows this design to become something else later that's really easy to use and really easy to hook up. I had a few private messages on how these were actually going to connect. A lot of people ask, well, just use CAN bus everywhere. I plan on doing firmware updates to these modules. I don't like really doing CAN bus. CAN bus is really designed as a short protocol. You can send it data. It is relatively fast. But the distance and what I can actually do as far as short circuit protection, I can actually do better on 485. I do plan on supporting CAN bus, but it's going to be on the controller side to actually interface with a RZR. And again, that's where your you know, reverse gear detection, speed, that type of thing is going. And it, you know, it opens up a lot of other possibilities that I'm not super interested in. I would like to do, but it's going to be, you know, a trivial thing to go in and add, you know, to look at the temp and actually intercept the actual fan control, and make the fan come on when you want it, to keep temps lower, just you know, PWM the fan to keep you know, your legs warm. So that's kind of where that's headed. But as far as this board goes, I think we've basically verified all the parts of the design, and I'll be sending off for another small run of prototype boards based on the new design. And we're going to work on, in the meantime, we're probably going to work on looking at what, you know, where we're going to put it in the RZR, how it would hook up. And obviously we've got a lot of work to do on the controller side of things, as well as CAN bus. But these boards should be in just a few weeks, and we'll assemble one, and at that point we should have something in the RZR at least to control the two items that I currently have in this default mode. But if you have any questions, suggestions, you know, maybe there's an idea I haven't thought of out there that is some interest to some people for control. I'd really not like to kind of have an idea what I'm going to do with that fourth input, and I don't have a good one, because again, these boards are going to be two inputs and outputs, and with 4 inputs, which I basically, just so you know, the reason that I did 4 inputs is because that's what the IC of the Opto comes in. I knew I needed 2 inputs at least to do the 2 outputs, but I also wanted that ignition sense. And on the RZR, that's actually on your terminal block, and what that does is tells, you know, when you turn off the key on my 1000S, it actually stays on for a few seconds, so you know, it'll leave your stuff on. But I'm actually going to adjust that and make it even a little bit longer. That fourth input, I really don't have a application for it. Like I say, it'll become more important on the 485. But if anybody has an idea of something related to winching or you know, the light, let me know. Really, the only thing I may do, unless I get a, you know, come brainstorm an idea here shortly, I may do like a slow pattern flash on output 1 with that switch on, and that'll be for my light bar. Like if I wanted to signal somebody or something like that. I really don't want a really fast PWM light bar, but I may want it to blink or do something like that, just so somebody can spot me from far off. Anyway, thanks for watching, and if you have any questions, drop me a line. Thanks.